Okay, so we're going to continue talking about atoms and elements today. You have lots of papers on your desk. Okay, I just had 4 papers passed out on your desk. Before we start talking about any of those, I want you to, just set it over there. I want you to open up your Science and Social Studies folder. Your science stuff should be on one side, your social studies stuff should be on the other. So currently, if you have them all mixed together, I'm giving you time to fix it right now. Science stuff, if it is for the scientific method, okay, if you still have scientific method stuff in there, you may take it out and you may recycle it. So really the only thing new paper-wise that we have, I believe, is the periodic table and your note cards. Periodic table and your note cards. If it's anything else, unless I'm mistaken, is there anything else over? Okay, and just put it in the recycling bin. Is that scientific method or is that? That's scientific method. It says it at the top. Okay, put them in the recycling bin outside the door. Says scientific, if it says scientific method on it. Kaden, is yours all cleaned out? It looks like you got a lot of extra stuff in there right now. That's scientific method, yep. You can recycle it, yep, we're cleaning it out. Yep, that's scientific method. That's scientific method, yep. Yep, toss it. Jude, pass one of these out to everybody. I'll probably run out, but that's okay. Okay, once you have your science side cleaned out, go ahead and just set it aside. Okay, set it aside. You still have papers on your desk that I passed out. One of them should look like what's about to come up on the board. Jude passed out these. What we're going to do, just to make it easier to find these science cards, is the baggie that you have your molecule, atom, element note cards in. You're going to make that. I know, I ran out. I'll get you guys some. Okay? I'm going to pass around a stapler. You're going to make that, clip it on, and then you're going to put it in the prongs of your binder. Okay? Don't you usually have social studies cards also? And you guys have a hard time keeping track of them sometimes? Yeah, a lot. So my suggestion is I'm going to pass around a stapler in a second. Put them in the baggie, okay? Put the thing on it so they don't tear. And then use the prongs in your folder. Most of you have folders with prongs on it. Okay, and I can make more of those things. So I'm going to put Sophie's in here just like this, to where anytime she needs her science note cards, they're right there, her science vocab cards. She could easily put social studies in the top 2 prongs also. They could overlap that one, to where your note cards are always in the same spot. Okay, so I can make more of the cardstock stuff, so you can make those for social studies also, and those that didn't get them for science, I'll get them to you. Maya. You don't have what? Prongs? Okay, then you'll just have to tuck yours. Okay? Or you could paper clip it in the front if you want to grab a paper clip or a binder clip. You could clip them in. I can get you a small binder clip in a minute. Finley. I can't hear you. Hurry up. Okay. Now, before we start science, you guys all have a piece of paper on your desk that has pumpkins at the top. I'm just going to read that to you. Has Miss Beer already talked to you about this? Okay. So it says on Thursday, October 28th, we'll be walking to Aveston Countryside Manor to sing Halloween carols and visit the residents. This will be done outdoors due to COVID restrictions at the nursing home. Your child will need a costume that includes no makeup, weapons, or scary clowns. Please do not think you need to buy a costume. Homemade costumes are cheap and easy, and the kids actually love them. Costumes can be sent to school in a plastic bag. You do not wear them, as we won't be going until 1 o'clock. We will not be celebrating in class with treats or goodies, so please refrain from sending any treats as this follows our school health and wellness policy. So we will start practicing pumpkin carols. Pull the door shut, please. To sing to the residents when we go there, okay? The residents really enjoy visitors, okay? Just think if you lived somewhere where you don't get to see a lot of people, and most of them are older, like grandmas and grandpas, and just think about how excited grandmas and grandpas get to see or get when you come to see them. So these people really do like the interaction with us, so we try and do it every year that we can. Last year we were unable to do anything due to all of the restrictions, but they have loosened them a little bit. Children are not allowed inside the nursing home right now, but we are allowed to go there, and some of the residents are able to come out, okay? Usually around Christmas we go a second time, which I don't think we will be able to do that this time. We usually go and play bingo with them, okay? So take that paper home. Finley, will you pull the door shut? Then pull this paper to the top, the one that has a big O, an 8, 15.999, and the word oxygen. What do you think this is? Harper?
One of the squares in that
One of the squares in the thing. She's not wrong. Who can add some more details? Haley?
an element in the periodic table.
It is an element pulled from the periodic table. Now, each of those little squares in the thing, or each of the elements on the periodic table, all have lots of information within each square. Today, we're going to learn what all of those little pieces of information mean. So, in the top left corner, there is a number 8. Look on the periodic table, if you have it handy, which all of you should. See if you can find one that has an 8 at the top. Maya, which one do you see? Yeah, it's the exact same one, just in a smaller version, right?
And it says number 16.00.
Okay, and on the colorful one, it says that this bottom number is 16.0. How could we go from this number to 16.0? Finley? Yeah, it was rounded, okay? Sometimes that number is rounded. Okay, let's talk about what these numbers are. The 8 up at the top. And if you notice on ours, the big one, it's kind of in the top left corner. On the colorful periodic table, it's in the top center. Both of those are correct. You might see it different ways. It still means the same thing. The 8 is called the atomic number. So I want you to label it the atomic number. And that is how they are ordered on the periodic table. So number 8 would be next to number 7 and number 9. Okay, so it's called the atomic number. But it also tells us something about that element. It tells us how many protons are in an atom of that element. So draw a line under that and put tells the number of protons. It tells the number of protons. Parker, do you have a question?
No, I
What is it?
It's an element.
So you're right. So he said the word oxygen is an element. The word is actually the element name.
What?
Okay, anytime you see the word, it is the element name. What do you think the giant O is? Dane? Okay, and it's not called an abbreviation, but it's called the symbol. Yep, so it's the element symbol. And some of the symbols make sense, some of them do not. Okay, so the element symbol for oxygen is O. That one makes sense. For hydrogen, it's H. That one makes sense to us. Find gold or silver. Look on the periodic table for gold or silver. Or iron. What's the label for iron?
It's
Iron is Fe. Gold is Ag. Silver is Au, I believe. I might have those mixed. It's been a while since I've had chemistry.
yeah, AU is gold.
Au is gold. I had them backwards. And Ag is silver. Is that right? I don't have it.
Silver, yeah.
Okay. So there's some symbols that will make sense to you. Okay. Some of them, what number is gold and silver?
79 and 47.
So 79 and 47. So the symbols aren't always the first letter of the element. Okay. And it's because some of them, there could be more than one that start with the same letter. Okay. But I just wanted to point out that the symbol isn't always like a shortened version of the name. Now, yesterday, what did we learn about protons and electrons? What did we learn yesterday about protons and electrons? There's a relationship between the two. Haley?
They're both located in the nucleus or whatever.
Not electrons. Electrons are on the rings. Harper?
They have the same number.
There's the same number of protons as electrons. At the bottom of this page, okay, you should have a little space down here. I want you to make a little star and put the number of protons equals the number of electrons. Now, when you get to high school, you'll dive a lot deeper into this stuff. There's isotopes, I believe is what they're called.
Isotopes like an atom, sort of.
Yeah, it is an atom, okay, but it's an unbalanced atom. All of the ones we talk about in 5th grade, they're the normal ones.
What number is the isotope for?
We don't talk about that here, okay? But what number have we not mentioned yet? Abby?
The 15.
Yeah, the 15.99999. That is called the atomic mass. Atomic mass. And then draw a line because we're going to say a little bit more about atomic mass. Haley?
Are we going to learn about like bonds or something like that? Something bonds.
No. Again, in 5th grade, we teach you kind of the basics of a lot of information. You will dive deeper into this in like Chem 1, Chem 2. Okay, atomic mass. The atomic mass is the number of neutrons plus the number of protons. So looky there, there's math and science. What do we know about the number of protons and electrons? They're the same. If we have information about these elements, which where is all of this information located? On a periodic table. We should be able to tell how many protons, electrons, and neutrons are in each of the atoms. Okay, that's what we're going to practice shortly. Right now we're still just giving you information. Parker, do you have a question?
Yeah, about some elements in the periodic table.
Mm-hmm.
How come some have maybe like 196.08 and some just have one whole number?
Because they're atomic mass. Usually a lot in 5th grade when we're working with the atomic mass, like this one's 15.999, we'd think of it as 16 to make our life easy. Okay? I'm going to pull up a different sheet. I want you guys to find the paper on your desk that says Adam's Notes. Adam's Notes. Adam's Notes. Adam's Family. No. Elements Notes. Hold on. Sorry, I thought I could find it quickly. Hopefully this is it. Nope. That's everything we have to get through. Not today. Okay, sorry. Let me look this up a different way. I thought I had it to where I could just grab it. See it? Oh, yep, there it is. Okay, so vocabulary. We've already talked about all this vocabulary. We're just putting it all together in one place. So first, where are protons located? Where are they located in an atom? Finley? Okay, you're right. The center, what do we call it? Abby? The nucleus. So protons are located, that's the first thing we're going to write. They're located in the nucleus of an atom. They're located in the nucleus of an atom. Okay, something new is that protons have a positive charge. So protons have a positive charge. They have a positive charge. And how do we know the number of protons in an atom, Parker?
It's the same number of the electrons.
Yeah, so try and fit that wherever you can. You might need to draw a line and use both. So the number of protons is the same as the atomic number. Lots of information there. Okay, where do the electrons, do you guys have one line for electrons or two? Two, okay. Where are the electrons located? Harper?
On the rings.
Okay, on the outer shells. Okay, so they circulate, so let's write circulate outside of the nucleus. On outer shells. Electrons have a negative charge. And how do we know how many electrons there are, Parker?
By the number of protons.
Yeah, it's the same as the number of protons. So I'm just going to put another bullet point. Same number as the number of protons. Now, you guys will dive a lot deeper into this later in the upper grades. But in general, just thinking about math, think of positive and negative charges going up and down. If there's 5 protons, so it's plus, 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 so it goes up 5, and then there's 5 electrons, minus, 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 what would happen? What would those pluses and minuses do to each other, Dane? Yeah, they kind of cancel each other out. Okay? The atoms we discuss here in 5th grade are all stable. Okay, which means that's true for all of them. Without getting too technical. Neutrons. What does the word neutron kind of sound like? Harper? Okay, does kind of sound like nucleus. I agree. Brant? No. Jude? Sounds like neutral. If something is neutral, what does that mean? If it's neutral, if I'm going to remain neutral on this. Parker, what does that mean? Nope, not calm. Bryce? Nope. Maya?
The same.
What do you mean?
Like the same pace.
Kind of. If let's say 2 of my friends are bickering, and you're like, I'm not taking sides, I'm staying neutral.
By yourself.
Yep, it means I'm not really going either way. I'm staying right there in the center. I'm not going this way, I'm not going that way. Neutrons have no charge. Okay? They're not positive, they're not negative, they are neutral. So we're going to put neutral charge. I'm going to put neutral in parentheses. I'm going to write no charge. They're not positive and they're not negative. They're neutral. Where are neutrons located? Parker?
Neutral.
Neutrons. Where are neutrons located?
In the center with the proton.
In the nucleus? So located in the nucleus. Located in the nucleus. Now, for how to find the number of neutrons, we're going to write a subtraction sentence. Do you have 1 line for neutron or 2? 2. Okay, so go down to the second line. Does everybody have this? Oops, I hope so because I just cleared it. So on the second row of nucleus, I want you to write atomic mass minus atomic number equals number of neutrons. I don't know if you remember, but yesterday when we were drawing one of our atoms, or the atom that it had us color in, didn't match that equation. There were only 3 neutrons, and there should have been more than that. But I went with what the picture said. So atomic mass minus the atomic number equals the number of neutrons. We're going to have to do those simple subtraction problems to figure out the number of neutrons. Okay, what is a nucleus? What is a nucleus, Lori?
The middle in the atom.
So the center of the atom. Center of the atom. And it's where what's located? What's located in the nucleus, Finley? Protons and neutrons. Okay, it's where the protons and the neutrons. Okay, outer shell. What is the outer shell? Sometimes they're called electron rings. Harper?
Those circles around the nucleus.
What happens there?
The electrons.
Yeah, that's where the electrons are. Where the electrons are. Okay, it's where the electrons are. Now, there are some important information about the outer shells. We're going to put the first ring right under this. I want you to write first ring equals 2 electrons. The first ring equals 2 electrons. If you look at the 3 atoms drawn below that, what do you notice about the first ring in all of them? What do you notice about the first rings in all of them? Maya? There's only 2 electrons. In that first outer shell, the one closest to the nucleus, there can only be 2 electrons. Okay? After that, most of the time we don't go out further than 3 rings. There's 8 max. Okay, so the first ring is 2 electrons. I'm going to put after that 8 max. What does that mean?
That means 8 is the max.
8 is the max that they can have. Okay, and again, that's not super important to us in 5th grade, but if I'm going to teach it, I might as well throw in stuff like that. What? It's not in here. It's in a different room. Okay, so now we're going to use all of that information. When we look at these atoms down here, it's showing you different ways to draw an atom. There's 3 different models below. We should be able to tell what element it is, how many protons, how many electrons, and how many neutrons, just by looking at the pictures of the atoms. Okay, does everybody have this? Okay, let's look below. I'm actually going to start with the one on the far right, and mine pushed it down. I'm going to start with this one. Okay, so it's the far right on yours. I'm just going to fill out the thing under it, even though mine looks different than yours. What do you think the P and the N in the center of the atom stand for, Max? Protons and neutrons. So for this particular element, Brady, how many protons do you think I have? 7. So again, mine looks different than yours. You just fill out the lines under it. So there are 7 protons. How many neutrons do you think there are, Harper? 7. How do I find my atomic number? How do I find my atomic number? Reese? How can I find my atomic number? If you need to, go back up to the top. Sophie?
You take protons plus neutrons.
Hold on, that's atomic mass.
Oh.
Where do I find my atomic number, Lori?
From the number of protons.
From the number of protons. If you look up on protons, the last thing we wrote is it's the same as the atomic number. So if your number of protons is 7, your atomic number is 7. How can I find my electrons in this atom? Dominic?
By counting how many are on the outer shell.
Yeah, I count how many are on the outer shell. So I'm going to mark them as I count them. 1, 2, 3, 4, 5, 6, 7. Atomic mass. Underneath it, it tells us we can take the protons plus the neutrons. So for our atomic mass, we're going to have a quick addition sentence. What's our quick addition sentence? Reese?
7 plus 7.
7 plus 7, which is?
14.
14. Now the hardest part, and it's really not that hard. We have to find this element on the periodic table. What is the easiest number up here that's going to help me find which one's my key to finding it on a periodic table? Sadie? More, like number of protons, electrons, neutrons, atomic number, atomic mass. Which one's going to be easiest to find? Lori?
The atomic number.
The atomic number is how they are ordered, okay? Because they won't always be the same, so you have to know that. In this one, no matter which one you picked, you were probably right because all of our answers are 7. So find the one that has number 7. Abby, what is it? Huh? Nitrogen. Nitrogen. Shh. Nitrogen. Check the atomic mass. What does it say the atomic mass is for nitrogen? 14.01. Is our answer close? Yes. Okay, let's work backwards. Does everybody have that? We're going to do this one next. I'm going to have to just put my answers. Mine's off. My margins are off, so it messed everything up. Okay, so we're going to do this one right here. I'm just going to put my numbers over to the side. Okay, I'm going to put P. I'm going to put them in the same order as yours. E, N, atomic number, atomic mass, and element. Okay? Kaden, how many protons does this atom have? 15. How did you know that? Because it says 15. Okay. Dominic, how many electrons does it have?
15.
Electrons? Now, why is this one different? Harper? It doesn't have the same amount as electrons as protons. So this is not a stable one. But what can I do to figure out how many electrons I have? Haley?
The number of things on the other side.
Yeah, I can count them. When I'm given the picture, I can easily count them. So here's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, so he was right. But I wanted you to count. Neutrons. Brady?
16.
How'd you come up with that?
It says 16 neutrons.
Because it says 16 in the nucleus. Okay? Finley, you with me? Where do I find my atomic number, Bryson? Where do I find my atomic number? How do I know what my atomic number is? Parker, I will never call on you when you're doing that. Okay? Promise. Haley?
Number of protons.
Yeah. The number of protons is your atomic number. So it is also 15. How do we find the atomic mass? Lori?
Adding the protons and neutrons.
Adding the protons plus the neutrons. So we're going to write 15 plus 16 equals 31. How do we find this element on the periodic table, Harper?
You look for the atomic mass on the.
Not the atomic mass. That one's harder to find.
Oh.
Which one helps us find it, Jude?
The number.
The-
Like whichever number.
Nope, not number 31. Bryce?
The atomic number.
Yes, the atomic number. I want you guys to draw an arrow from right here down to here. So you know the atomic number is the one we need to find it. What'd you find, Brant?
It's like a
pH. Says pho. Phosphorus. P-H-O-S. P-H-E-R-O-U-S. Phosphorus. We're going to skip that first one because it's just kind of ugly. Which ones do you think are the protons in it? If they have a positive charge, Maya? The ones with the pluses. Okay? The ones with the pluses would be your protons. But I want you to flip your Adam's notes paper over. And I want you to circle A, B, C. Circle A, B, C. What is the title of that backside called? Lori?
which atom is which?
Which atom is which? Find the other piece of paper on your desk that is titled Which Atom is Which? It has pictures of what? Atoms. I want you to try A, B, and C. Look up in the top right corner of that piece of paper. What does it tell you?
Nucleus.
It tells you that in the nucleus, the neutrons are the circles that are colored in, and the protons are the ones that are not colored in. That's going to be important when you're counting them. Okay, so I just want you to try A, B, and C on the Which Atom is Which worksheet for homework. Does that make sense? You will need your periodic table as well as those two pieces of paper. So you'll need 3 pieces of paper to complete that assignment, those 3 problems.